All right. So for today's lesson, we're going to introduce you to different types of sampling methods. And we're going to see how those methods can get rid of any inherent bias. So I thought I'd start off today's lesson with an example. A political researcher is trying to estimate who's going to win the next presidential election. So to study this matter, they thought to themselves, well, I need to take a sample. So they went to a large shopping center where a lot of different type of people congregate, and they randomly sampled 1,000 people by asking them who are they going to vote for. So now what we need to consider is this a good sampling method? If it is, comment on why it's a good method, and if it's not, comment on why you feel that way. So pause the video and spend about a minute trying to figure this one out. We're back. Hopefully after you've had a few moments to think about that problem, you've come to the conclusion that this was not a good sampling method. And that's true for a multitude of reasons. Now, while they did randomly sample people at that shopping center, we need to realize that that shopping center was in a specific city or a specific town or a specific state. And only people who went to that center at that particular day or time could have been selected. This sampling method is biased, right? We don't want to have a biased sampling method, otherwise it's not going to yield accurate results for what we're interested in. This may have given us a good representation of who people at that shopping center would vote for, but not a good representation of the whole United States. A bias is any systematic overrepresentation or underrepresentation of certain characteristics or traits from your population of interest. In this case, we overrepresented people who went to that center and underrepresented people who didn't. Now, we should think about what are the different ways we can get rid of inherent bias, because bias is bad. We're going to spend a lot of time in this course thinking about ways to get rid of bias, or at least in this next lecture. If you have a biased sample, you're not going to accurately estimate the population that you're interested in. How we are going to get rid of bias, how bias is eliminated, is by introducing randomness. Randomness is key. Randomness favors no one. It has no inclination. When you introduce randomness into a sample, you'll get rid of bias. And so what we're going to do is we're going to talk about 3 different sampling methods that introduce randomness. So the first sampling method that we're going to learn about today is what's called a simple random sample, or SRS for short. And this gives every single member of the population the same chance of being selected. This is getting rid of any inherent bias for us. Every single person, every single U.S. voter rather, has the same chance of being selected, regardless of where they live, what their ethnicity is, what's their income level. Everybody has the same chance of being selected. So one way we could do this is to put everybody into a big hat and, everybody's name into a big hat and randomly pull out, let's say, 1,000 names. Or we can assign everybody a number, all U.S. voters a number, and randomly pull out or select 1,000 numbers. Now, there's some benefits to this sampling method and some downsides. Right, one that we talked about is everybody can be selected. Everybody has the same chance of being selected. And it's not biased in and of itself. However, though, there are some things we need to consider. Imagine we did this in practice, right? We were trying to estimate or predict who is going to win the presidential election, and we randomly pulled out 1,000 U.S. voters. Is it possible, for instance, that we pulled out 1,000 people all from California? It technically is. It's not likely, but it's possible. Right? You can still end up with, unintentionally, a biased sample when you perform a simple random sample. by sheer chance. You didn't intend it to be biased, but it's possible you can end up with a biased sample. Maybe you selected 500 people from California and 500 people for Texas and didn't represent the other 48 states. We also need to consider that how are we going to get a list of all, 250 million potential U.S. voters? That's going to take a lot of time, effort, money, and resources that we probably don't have. So while this is a completely random method, there are some downsides into performing this. So another type of sampling method that helps fix some of the issues that an SRS has is what's called a stratified random sample. And what this does is it breaks up your population into groups, which it refers to as strata, but you can still think of this as groups. And then it performs a simple random sample from each group. So for instance, if we were trying to predict the U.S. election, the winner of the U.S. presidential election rather, we could separate United States voters into East, Central, and West. And so then what we would then do is we would randomly select a certain number of people from those three regions. And in doing so, we would be able to better represent the United States as a whole. Now, you don't need to select the same number of people from each group or each strata. You can select a different amount of people based on the size of those strata. So, for instance, if there's more people living on the west side of the United States compared to the central, you would want to represent that in your sample. So the benefit of this sampling method compared to a simple random sample is that it can guarantee you represent observations of a certain type. A simple random sample cannot guarantee that you would represent all of the groups that you're interested in based on your population. So there are a lot of advantages of working with a stratified random sample, in that you break up these observations into certain groups and you randomly select observations from every group. However, there are still some downsides to a stratified random sample. Again, this method can take a lot of time, effort, money, and resources. I mean, how are we going to contact random people from the central United States, random people from the eastern United States, random people from the western United States? I mean, that's going to take a lot of time, effort, money, and resources. You'll also run into issues where if you don't select the correct percentage of observations from each group, for instance, if there's more people in the western United States than there's central, and you selected the same amount of people from the west and the central, well, in that case, you would be biased. You would be overrepresenting central United States people and underrepresenting western United States people. So if you're going to perform a stratified random sample, you want to make sure the percentages of each group match up with what you're sampling from each group. So the two sampling methods that we covered, simple random sample and stratified random sample, both of those methods can take a lot of time, effort, money, and resources. So the last one that we'll cover, called a random cluster sample, that's going to be the easiest for us to accomplish. And what this does is similar to a stratified random sample, but it breaks up your population into groups, which in this case it calls clusters. So you can think of strata, clusters, and groups as synonyms. They all essentially mean the same thing. And so for a random cluster sample, though, how it's different from a stratified random sample is that it doesn't select observations from every group. So if we were trying to predict the presidential election of the United States, and we had our three regions, West, Central, and East, for instance, we could randomly select people from one of those three regions, maybe from the West, maybe from the East. We can select all of people from a certain group. We can select a subset of people from a certain group. We could even select two groups, two whole groups, simple random samples from two groups. The only real difference between a stratified random sample and a cluster random sample is that you're not selecting members from every single group in a cluster sample. A stratified random sample, you select from every single group. Now, this is going to be beneficial for us because it's easier to perform. Right? If you're a researcher in the western part of the United States, it's probably easier to get observations or take a survey from people who live in that region. It breaks up these the population you're interested in into groups. It's going to be your easiest way to get a sample. However, though, the big downside to this, maybe you kind of came across it, is it's going to be biased. There's no way to avoid that. Because you're not selecting observations from every single group, you're guaranteed to end up with a biased sample. The only real reason you would want to do something like this is because it's the only thing you have available. You just don't have the time, effort, money, resources to take or to get an unbiased representative sample. In reality, companies that try to predict the presidential election, they'll spend millions of dollars to get a sample of just about 3,000 US voters that's unbiased and representative. It can be very difficult to get that. So a lot of the times, the only option that some people are left with, or some researchers are left with, is taking a random cluster sample. Is it ideal? Absolutely not. But is it sometimes the only thing that's possible? Yeah. So these were the three sampling methods that we'll cover in this course: simple random sample, random stratified sample, and a random cluster sample.